Hello everyone. Today I will be showing you our project on building a system that autonomously learns how to play Pac-Man. Our project heavily depends on the Modular Agent-Based Evolution Platform, or MABE, so I will be explaining what it is and how it works. As the name implies, MABE gives us the ability to evolve agents. We can see the basic structure of MABE by looking at this diagram. There are 7 main components, and the ones most relevant to this project may be the brain and the world. When we run MABE, worlds are created and agents are put into these worlds. These agents each have a brain that takes in input from the world and returns an output that controls the actions of the agent. Depending on the world, the agent is given a score, and individuals with the highest scores are selected to produce offspring for the next generation. So the brains evolve over generations to get a better and better score. For our project, we choose to focus on Markov brains, which in a short experiment has shown the most potential as an agent that can learn to play Pac-Man. In this figure, we can see that compared to other brains provided by the framework, the Markov brain achieves the highest average score out of all of them. So what are Markov brains? Markov brains are neural networks built from individual computational components called gates. Users can choose to use different combinations of gates in the brain. Certain gates may be more suitable for one task, and others may be suitable for another. In a single brain update, all of the brain's gates are run in parallel to read from nodes and write to the output nodes. The Markov brains can be encoded by a genome, which is simply an array of numbers. A start codon tells the decoder to start reading the next sections, which defines which gate it is, how many inputs and outputs it has, and which nodes it is connected to. Each generation, the genes of the best performing agents are chosen to produce the next generation. The genes are randomly mutated using insertion, deletion, and copy. These random mutations cause evolution to take on different paths. For our world, we converted a remake of Pac-Man written in JavaScript and converted it to C++ because MABE is written in C++. The code can then easily be integrated into MABE by coding up a simple interface between the game and MABE using the given world template. This allows us to control what input is given to the brain, how many brain updates do we have between each game update, and how do we interpret the output. We performed experiments by comparing how Markov brains with different gates and number of brain updates perform. Evolving over 10,000 generations, the most successful brain is the brain using genetic programming gates with one brain update. It reaches an average score of around 1200 to 1400, and the highest score is 2840. Feel free to head over to our website and play the game yourself and compare scores with our computer.